Yum, yum!
Greg here from Pixel Fondue. Happy Friday. So this video is going to cover a series of nodes called probe nodes. Now, I think these are really underutilized. I'm going to try and show some what I think are really practical uses for them. And a lot of 3D work, if you've done a lot of production work, I think you'll agree 3D is often just a big exercise in problem solving. So trying to figure out solutions to problems or desires from clients or whatever. And probe nodes are just another tool in the toolbox to solve problems. In this particular video, I'm going to be talking about Steve Hill's Emmy Kit. There's two or three, I think three actually, new probes that come with this kit. There's the map probe, which lets you probe any vertex map. So you can probe a morph map, the values of a morph map. You can probe weight maps. You can probe UV maps. You can probe color maps. You can probe all these different particle maps like particle size and things like that that are embedded in a vertex map. There's also a UV map probe, which we will get to in a different video, which is super cool. And then there's also a force probe where you could probe forces in the scene at any point. So there's just a ton of different use cases for these. So I'm just going to show a couple use cases for the map probe. In this one, I'm going to show it hooked up to some channels and show you how that works real quickly. And then also show you how you can hook up a gradient to it and use it for shading. So it just works like all the other probes I've been doing. If you've been following these videos, I'm just going to pop open the schematic here. That is not the schematic. This is the schematic. And I've got my plane, and I've got a locator in here. This little white cube is the locator, and I've got the sphere but parented to it. So I'm moving that around, and I've got a UV map on my plane here. If I look at the UV map, it's just regular UV map from 0 to 1, filling up the UV space. And I've got an image on there as well, just showing where it's 0, 0. That would be this corner down here, and going up to 1, 1 in the top right corner, right? Just like any UV map. So let's take a look at a UV map probe and how that works. So I'm going to flip that back to the schematic. I'm going to add the map probe, and again, this is from the Emmy Kit, which is available on Gumroad. I'll put the link below. So it wants a triangulated mesh. So this mesh is not triangulated, so I'm going to just add a quick triangulate mesh operation on there. There it is. MODO search needs to be better. Every time I type in triangulate, it puts detriangulate first. It seems like the search should be smarter than that. Anyway, we'll put in the triangulate mesh op. So now this is triangulated. You can see the mesh is bunch of triangles. Now the reason it needs it triangulated is there's some I don't know exactly. There's something with the calculations that needs a triangulated mesh. Now, if you don't want to triangulate your mesh, you can always just merge this current mesh into a new mesh item, triangulate that, and use that as the input to the map probe, and just hide it and keep your non-triangulated one visible. Now, this may be something you want to do with if you're doing like a sub D character or something like that. So basically, just really quickly, you would just add a new mesh item. You would do a merge mesh operation. You just merge in your existing plane, for instance, and then you'd also add the triangulate there to this merged one, and then on your original plane, I'll just take off triangulate. So here my original plane is not triangulated, right? But this sort of clone of it that I have merged over here is triangulated, and I can use this as my input to the triangulated mesh, just keep it hidden and keep my, it'll just follow along. It doesn't matter if your original mesh is deformed or transforming, whatever, it'll follow it along perfectly. So you can use that if you're animating or if you don't want triangles, essentially. But in this case, I'll just keep that hidden. We'll just use our regular plane here, and I'm just going to triangulate it, right? So we'll plug that in, and then we'll plug in our locator here to the position channels. So I'll just plug in the position. Again, you can just drag in those position channels and plug those in like that. Now, this is just going to, let me just set this up again. this map probe here has a whole bunch of different maps it'll look at, like I mentioned, like normal maps, RGBA, relative absolute morphs, weight maps, particle size, whatever. We're going to look at texture UV, and then you just need to type in the Vertex map name. Here is just texture, right? So it'd be kind of nice to have a drop down probably, but that's fine, because if you spell it wrong, it's not going to work, and you're going to wonder why it's not working. But this is going to work. So if I look in here, and I see the locators at the center, that should be 0.5, 0.5, right? That should be the two values that are returned. So let's look at the channels, and I see here 0.5, 0.5, right? And if I take my little locator here, and I drag it down to the corner, whoops, I want to make sure I'm in item mode. Take my little locator and drag it down to the corner where it says 0, 0, we should be getting 0, 0 returned. And again, you just have this XYZ value returns here in the alpha. If it's a weight map, it's just one value, so it returns the X channel. If it's a UV map, it returns the X and Y channels, U and V. If it's a morph map, it'll return the offsets, the XYZ position offsets of that vertex in a morph from its non-morph position. So those are the results you can use, and you can just plug those into whatever you want. So if I want to animate the scale of the sphere, or say, yeah, we'll just do the scale of the sphere based on this XYZ, or based on the UV maps, what I'll do is I'll just drag my sphere's scale channels in. Let's just say the X and Z scale like this. So here's my sphere scale. And then I'll just plug in the X and Y results there. So the U and V go to scale X and Z. And when I move this around my map here, you'll see that the sphere will get full size when it's 1, 1. There we got flat and 1, and here we have flat on the Z, because that's the Y is, the U is 0, back to 0, 0, 0.5, 0.5. So you can see that this can be a useful thing, right? And we can also use a weight map. So this guy actually has a weight map as well. So let's look at the weight map. We'll just let it load in. Again, we've got this sort of black thing in the advanced viewport while it's calculating or doing a shader compilation, and hopefully they can speed that up or get rid of that sort of black thing there, or at least give us like a progress chart. I don't know why it takes so long. I have a 3090 in this, but hopefully, I know they're working on it. They've got some really good engineers there. Anyway, so we've got a weight map here, and so we're just going to change our map probe from UV to weight, and we'll just type in the name of the map, which is weight. And again, the same thing is happening, right? This time, it's just result X. There's just one value for weight value, so we'll just plug X into both of these. And then when I move my locator around, I'm getting different scale values based on the weight, right? So now, again, this is just a problem-solving tool. If you do a lot of animation, in particular in MODO, you're always going to have to figure out how to do something, right? And this is just another tool to use to pipe values around the scene and get values from the scene to drive animations or drive attributes or shader tree attributes from Vertex Map values. So it's super useful that way. And so let's take a look at another use case for this, like with a gradient. So in this scene, I've got this head here, and I have a vertex map on it. And this vertex map I created with just a set map mesh operation with a texture fall off on there. I have like a sort of a Voronoi noise texture fall off, and I have this kind of cool looking texture map, right? Or a vertex map. So let's say we want this vertex map to drive a gradient for shading. So I add a gradient, processing, gradient, and I'm going to put that in the head. Again, I always want to check on my gradients texture locator to make sure it's zeroed out, because all the time, it tries to auto size to the head. So we want it, 111 for scale and zeroed out. So there's our gradient, and we'll just drag them both over here to the schematic. I already have my head over here, and it's already triangulated. And I'm not sure where this texture locator came from. This may have been a test locator. That's just the locator in the scene. So we don't need that right now. So let's load up my map probe. All right, and let's plug in my triangulated mesh, and we're going to plug in the texture locator's positions, texture coordinates to the position channel, and then scooch over my gradient, because I'm going to plug in the result into the initial value, right? fact, I want to be really specific here, result X. It's just a weight map, so there's just one value that's in the X channel, the first one, right? So I'll plug that in here, and then that should be driving the gradient now. So if I double click on my gradient, I believe gradient color, it'll pop up. There we go. Although it auto selects alpha, which I don't like. I want that unselected. So I'm just gonna, let's just do some colors in here. Let's do some yellows, maybe going to blue, put something in the middle like a purple. And let's take a look at this in the preview window. And there we go. So we're driving this gradient with the weight map value. All right. So that's a useful thing for the map probe. But if we want to do something, I don't know, let's do something weird. Let's drive the gradient with a morph value. All right. So this is going to be sort of interesting. So let's go back to the schematic here, and I'll go back to my face. I'm just going to deselect this weight map so it goes away. And I don't really want to see this gradient in the viewport, so I'm going to click off GL display. Now this particular head is from a tutorial I did earlier, which I should link below, where I go through a bunch of morph maps. This is actually a head you can get on 3D Scan Store for free to get all these facial expressions for free. So this has a ton of morph maps on it, right? See all these morph maps here? There's a ton of them. I think I made some into, yeah, I've got some various of the morph maps turned into morph deformers. Let me just, they're all going at once here, so let me turn those off. But I can, for instance, just select strength, and I can press C for channel hall, and I could do my anger map, right? Pretty cool. So what if I wanted a gradient to show me which vertices move the most, sort of a heat map of vertex movement, right? So I want to probe the movement or the magnitude of movement from these vertices on one of these morph maps, and I want to pipe that into a gradient, and so we can view that, maybe use it for shading, right? So let's take a look at how to do that. So we've got our face here, right? In fact, I'll turn that back to 0. And we already have this sort of set up. We're going to change our map probe from weight to relative morph. And remember, I need to type in the correct name here. So I'm just going to select this and then select the name over here and Control-C copy, go back to my map probe and just Control-V paste it in there, 27 anger pain. And then I'm going to, now remember, since it's a morph, it's probing the positional offsets of each of these points. And so here, why don't I actually use my test locator and show you how this actually works. So let me put my locator into position for the moment instead of the gradient. And where's my locator on the screen here? We just turn it back on. Let me just move. So it's on the lip right here. You see the locator right there on the lip. And I know that the lip moves quite a bit in this anger morph. If I go back to the anger morph, I think I could just get it here to save some screen real estate. Let me just select the anger morph here and increase the strength here. So if I go like that, I know that there's a lot of movement on that vertice on the lip there, right? So what is this map probe returning to me in the values? I look at the vertex map values, whoops, so the channel values here, and you see it's got some positional values, right? It moves a little bit, like, these are just millimeters, about 5 millimeters in Y moving up, and just a little, like, a few millimeters in Z as well. It doesn't really move in X. If I take this locator here and I move it, let me just X snap to vertice, and I say I move it to a vertice way over here, like on the cheek, that's not really moving. You'll see that the results are really tiny. It barely moves at all. So it's returning the XYZ positional changes of those vertices. That's what this map probe is doing. But what's cool, of course, is when I use it with a gradient input, I get all these positions sort of at once. And again, let's make sure this gradient is zeroed out and 1 on scale. It is. Let me turn off my verts here. And yeah, so for the, now I've got these 3 positions, right? I have an XYZ position, but I only take 1 input into my initial value for my gradient. So I need to change these 3 positional values into a magnitude. And so I've got a node for that in MODO, and it's like a vector to magnitude node. It'll take a vector, which is those 3 positions, and it'll change it and give me a magnitude. So we just do vector we'll just actually type in magnitude maybe. There it is, vector magnitude. So hit enter, I've got my vector magnitude mode. It likes these 3, it likes an array, so I can take these guys here. Let's unplug it from there, let's plug it into here, and now I've got a magnitude, and I'm gonna plug the magnitude single value into my initial value there. And that's going to give me an interesting looking gradient. So let me just double click the color here again, and this time I'm going to just go from, let's go from red, so that's the greatest magnitude at 100%, and we'll just go to white at 0%, and let's see what this looks like. Now, I'm not seeing anything in the viewport or in the render view, and this is one of those unfortunate situations where everything's hooked up right, we're just off by scale. So the magnitude is actually really small on this. It's a really small number, so everything's in the white range of the gradient. They're just moving millimeters. So what we need to do is just bump up our magnitude value a little bit, and we just do a multiply node in here. So I'm just going to do a quick basic math multiply and plug in my magnitude in the top one and type in 100 in the bottom one. So we're just multiplying the magnitude by a factor of 100 to sort of stretch that magnitude value out along the bottom of the x-axis of our gradient. And then now it should be extending into the red range. And here we go. So it's like a heat map of the morph map, right? So if I go to my head here and I go to the anger and I say 100, there we go. Looking all angry, or anger pain, I guess. Whatever. I'm not sure what that is. But, that's the reddest pixels are the vertices that move the most, right? So you can imagine using this for something. There's, always, whether you're doing motion graphics or medical animations or product animations, and you can see where some magnitude of a morph you may want to show in a render, or you may want to drive a different channel, like a transparency channel or something like that with this probe. You can even imagine having a whole bunch of different morphs. Like this mesh has something like, I don't know, 20 different morphs on it or something. 28 different morphs on it, giving a different color for each one and iterating through them and having all these different colors coming up and blending together on the face would be kind of a cool effect or something. So there's all kinds of cool stuff you could do. But here it is. This is just using you're probing a morph map and getting the magnitude of those offset vectors and using that to drive a gradient. So it's a pretty cool thing you could do.
Yum, yum!